Okay, so this is number 6. So in step 1, a strip of paper 6 centimeter wide, which is this much, is folded as we given in the step 1 picture. And in step 2, we just unfold this paper to create a crease labeled PQ, which is this one. And step 3, a second fold is made through the point Q so that the edge of the strip coincides with the segment PQ. So which means we take this part and then using the QR, we just, I guess, reflect over QR to get this piece over PQ. That's basically what this says. And in this step, in the step 4, we just unfold this backward and then put it back. And by this info, so we are given that the area of the PQR, which is this triangle, is 36, and find the QR. Okay, so I hope that was clear. So if you didn't really get what's going on, so take a look at pause the video and take a look at and kind of remember, make sure you understand the question. Now we have the question, right? So 36 as the area. So first thing that we have to remember, if you are trying to like fold this picture over this QR, so we should see that this piece right here has to be same as this piece because we are taking this one and reflecting over this one. So when you fold this way, so that piece is the same as this piece. And at the same time, the angle right here is the same as the angle right here. So because we are just, this angle just coincide with this angle, you know, for this side to be on top of this PQ. So that is also something we have to remember. And so now we have those information, but at the same time, you know, what we were given only is this distance, which is 6. So like if you draw this like height or if from here to here, that will give us some idea, but let's see if we can do something else before we do some other drawing, right? So I'm gonna connect this point to this point. The reason I'm gonna do this, because we know that this segment, let's call this is T, QT is congruent to QP, and then QR is congruent to QR, and this angle are congruent, which means TQR, okay, TQR is congruent to PQR by side angle side congruency. So which is why that will make PR and RT is also congruent. So which is why we want to write that as well. So if I drop the altitude from Q to PR, so that is 6 units, right? And then that times PR, so let me write it here. So 6 times PR, which is the base, and then divided by 2, that will be 36. So from here, so we know that PR is just 12 units. So this is 12 units, and then that's gonna give us 12 as well. So now we have 6 and 12, so which is why this is nice, a 36 to 90 triangle. So where this is 30 degrees and this guy is 60 degrees, right? And I do know this angle was congruent this one, so this T, right? So it's the same as this one. So this one same as this one. So meaning that if this is 30 degrees, then the what's left over is 150. So it's going to be half and half. So 75 and 75. Since this is 30 as well, this is 75, this is 75, which means this QT is the same as RT. So which is why this is also 12. And this is also 12. Okay, so these are all good because we are almost getting there to get the QR, right? So after this point, I'm gonna make this picture a bit bigger because it doesn't look like we can kind of see in that small triangle. So I say this is QR, and then this is QT, and then this is RT. So this is Q, this is R, and then this is T, and this is 30 degrees. So what I'm gonna try, you know, this is 12, and then this is also 12. I'm gonna try to make a 30, 60, 90 triangle because we like those triangles to get the QR. So if I drop altitude from R to QT, right, then this is gonna be a 90 degrees, so that will be 60. So the hypotenuse is 12, which means 30 degrees should be opposite the half, which is 6. We already actually know that because this height is the same as whatever height from R to QT or Q to PR. So that should be 6, which is kind of confirming our approach. And if this is 6, so that other line will be 6 root 3. And then this small piece right here is going to be 12 minus 6 root 3. And we know this is 6. This is a 6 minus 6 root 3. And the hypotenuse is what we are looking, so which I'm going to call x. Since we are allowed to use a calculator, so I'm going to go ahead and use the Pythagorean. So that will be 36, which is 6 squared. And then plus this guy squared, so 12 minus 6 root 3 to the second power. And since we want to find the x, so I'm going to take the square root. And then that will give us x right here. So at this point, I wouldn't bother myself to deal with this expression as long as I have a good calculator like that I can plug this into easily, then I can just get my answer as well, okay? So if I plug these into my TI or something similar to, so I will get 6.21165. So if you want to find the nearest 100, so you will get 6.21. So that is going to be our answer. So this is one way we can try this problem, but the second approach I'm going to try using is just because I seen a question on the chapter round like a couple of weeks ago, I guess 3 weeks ago, that I actually had a video about as well. So that was sprint number 30. And then the MATHCOUNTS official solution provide a way to do that problem by using another special right triangle, which is 1575-90 triangle. And then if you remember that video, I actually did that question without using that special triangle, but I said it is good to know that as well because that might be helpful. And in this case, we can do this problem as well using like 1575-90 triangle as well, even though we just got the answer a bit easily. But since this is the second time in the same year, so I'm going to kind of go ahead and remind that as well, because it looks like it's approaching that they're going to ask those soon a lot as well. So what I'm trying to say, so as soon as we have this much maybe from the problem, right? And the goal is to find a triangle with 75 and stuff, right? But before we kind of move on, so let me just remind what that looks like. So I'm gonna just do some side work here. So let's say we have a triangle, right? So I'm gonna say this is 15 degrees and this is gonna be 90 and 75. So the goal is just to make a triangle that where we have some other properties, which is nice to have 15, 36 and 90. So for that reason, I want to split that 75 into 15 and 60. So if you add these two, so that's 30 degrees by the exterior angle theorem, or that's 60, 90, 30. So we have this now. So if I name this is x, which is the angle opposite 30, so the other side, other leg will be x root 3, right? And the hypotenuse will be 2x. Since this is isosceles triangle, so that means this is also 2x. So the goal is to find the hypotenuse. I'm going to call that C, and I'm going to use the Pythagorean, okay? So the x squared plus the sum of these two guys is equal to x times 2 plus root 3. And then we are going to square this, so that should be x squared and square of this guy. And then this is equal to c squared. So if I take the square root of this guy, this whole expression, that will be my c. Okay, so let's simplify a bit. So that was x squared. And then if you square this one, that will be square of binomial. So 2 squared will be 4. And then root 3 squared will be 3. If you add those, you will get 7. So 7 times x squared. And then 2 copies of the product of these two will be 4 root 3. So that should be 4 times root 3 x squared. Okay, so that looks getting a bit bad expression. So if you combine these two, you got 8 x squared plus 4 root 3. And I'm going to pull that x squared outside. So I'm going to take that x. And then we have this. So at this point, it looks like we got the hypotenuse in terms of something, but it does not look nicer. So we can just do a bit more better like expression, I guess. So if you don't really know how to deal with this expression, I kind of did another like video, maybe I did like 4 or 5 questions in that video to explain how we can deal with the nasty radicals by using square or binomial. I'm going to attach that video into this video like description so you can review that as well if you kind of don't know what's going to happen after that. So what we are going to do, I'm going to put this number 4 inside of the radical leaving 2 right here. So let's try them. So that this is going to be 2 times 2, like 2. So if I take the 2 inside, that will be 2 times root 12. And then this is going to be 8 plus 2 root 12. And if you are wondering why I just did that way, I want you to look at that one. But the goal is just to make a perfect square inside. So this is 6 times 6 plus 2. This is 6 times 2. So which means the inside of this expression can be written as root 6 plus root 2 to the second power. And then that's under square root. So we have already x outside. And if you expand this, you will actually get this guy. So then you cancel the radical and the 2. So you will get x times root 6 plus root 2. Okay, so now we got the c as x times. Okay, so the x times root 6 and root 2. Okay, so it doesn't look nicer at this point, but let me clean this part. So this is a one relation, so you can leave it as it is, which means if I have the smaller leg as x, the longer leg will be smaller leg times 2 times 2 plus root 3, and the hypotenuse will be smaller leg times root 6 plus root 2. So let me clean this a bit. Okay, so I'm gonna take all of these and then just write the final result. So we got that the other leg was 2 plus root 3 times of the smaller leg, and the hypotenuse is x times root 6 plus root 2. Okay, so but to make this a bit better looking, we are gonna do a bit algebraic manipulation as well. So what I'm gonna do, I'm gonna multiply each leg by the conjugate of this expression. So we have root 6 plus root 2, right? So if you multiply root 6 plus root 2 by root 6 minus root 2, so that gives me, will give us 6 minus 2, which is just 4. And then if you multiply this leg, which is 2 plus root 3 by root 6 minus root 2, right? So that will be 2 times root 6, 2 root 6. 2 times this will be minus 2 root 2. And then these two will be root 18, which is 3 root 2. And then this time this will be minus root 6. So if we simplify this, 2 root 6 minus root 6, just root 6. And then that will be plus root 2. So meaning that when you multiply 2 plus root 3 by this, and then I got this guy. So instead of writing this, I'm going to replace that 2. The root 6 plus root 2, you can just include x if you want. And then instead of doing this, we are going to write just 4. And if you multiply this leg by the same number with that we multiply other legs, other side, root 6 minus root 2. So this guy would be root 6 minus root 2. So now this is a way better expression than the previous one. So the smaller leg is root 6 minus root 2. The longer leg, root 6 plus 2. Hypotenuse is just 4. And then that's our proportion in this triangle when you have 15, 90, and 75. But if you remember that video that I mentioned, there was another relation which I left as a challenge. So the other relation that we had was the relation between the height from the 90 degrees to the hypotenuse and the hypotenuse. So if you drop this altitude, okay, so the hypotenuse will be 4 times as much of this altitude. So which is why this is going to be just 1 unit. So, and then this is the proportion in this triangle that I kind of want you to take a look at and kind of put on your own as well. So you can actually remember, because this is going to be useful. This is the second question that I seen this year only, that MATHCOUNTS actually kind of asking us to use it. So let's use now this in our problem, because in the previous problem, we didn't really simplify the radicals, right? Because we could just use into like plug in calculator, that's what we did. But if we had to kind of write in exact form, if this was in sprint run, then we should have to deal with those radicals as well. So which is why this might be a bit better in that case. So now let's look at our question, right? So we had this triangle again. So I'm going to try drawing something like this. So, okay, so that is my QTR. And then what I will do, I'm going to drop the L2 from here to here, as we did in the previous approach. And then this was a 12, and then we had this 30 degrees, and this is 60, so this is 15, and this is 75. So 30 degrees is opposite to 6, and then we know this is 6 root 3. So we can say still this guy will be 12 minus 6 root 3, but let's try kind of using our relation right here. So the 75 degrees is opposite to 6. Okay, that's the ratio. And the hypotenuse is what we are looking. I'm going to call this is x. And then this ratio doesn't change when you make another triangle with the same angle. So this ratio has to be same. So in this triangle, 75 degrees is opposite to this leg, which is root 6 plus root 2, right? So root 6 plus root 2 divided by the hypotenuse is just 4 units. So if I simplify this now, so you can do cross multiplication and get x alone. So that will give us 24 over root 6 plus root 2. And then if I want to simplify this a bit, so that will be root 6 minus root 2 divided by root 6 minus root 2. So then denominator will be just 4, right? If you multiply this, and then you got 24 times root 6 minus root 2. So which will give us 6 times root 6 minus root 2. So again, we could just plug into calculator right here. As I mentioned, if we want to find a exact form instead of just plug into calculator, so then we could just leave as this one. But if we want in near the standard, so you can still plug this into calculator, and then that will give us the same result as well. So I hope that was clear. So we did this question basically 2 different ways. But the key takeaway from this problem, I would say, is the 75, 15, 90 triangle. And I will ask you to see if you can prove the 1-to-4 ratio by using the area of this triangle in 2 different ways, or you can use some maybe trick, but try not to use any trick in this problem. So, and see if you can find that relation as well. Okay, so I'll see you in the next video.